Lesson 5.4 is about dividing polynomials. So in this first lesson, I'm going to show you how to divide polynomials using long division. The rest of that stuff will be in another lesson. So to begin with, we're just going to do regular old long division, just like you learned back in elementary school. So if I want to divide 21 into 672, I notice this is a two-digit number, so I try to divide it into the first two digits. To decide how many times 21 goes into 67, I mostly just decide how many times does 2 go into 6. Since 2 goes into 6 3 times, I'll write the 3 over top of the 7. Once I have determined that 3 is my number, then I multiply 3 times 21, which gives me 63, and then I subtract, which gives me 4. Once I know that I have 4 left over, I can bring down the 2 and see how many times 21 goes into 42. Since 21 goes into 42 2 times, I put the 2 up here, multiply, subtract, and I get 0. This tells me the remainder is 0. So that means 21 and 32 are factors of 672. Okay, that's just plain old long division. So now if we're doing synthetic long division, you do it in a very similar way. So we have a binomial here, so I'm going to divide this binomial into the first two terms of the trinomial. So I'm going to see how many times 2x divides into 6x squared. So I have 6x squared divided by 2x equals 3x. I'm going to put that answer 3x over the 7x because I'm dividing two terms into two terms. So that goes here. Then I will take, just like I did over here, I'm going to multiply the 3x times the 2x plus 1. This gives me 6x squared plus 3x. Then I will subtract, just like I did over here. When I subtract, I have to subtract both terms. So 6x squared minus 6x squared equals 0, as it should. And then 7x minus 3x is 4x. Next thing I will do is bring down the 2, just like I did over here. So that gives me 4x plus 2. Now I see how many times 2x plus 1 goes into 4x plus 2, but mostly I'm focusing on just 4x divided by 2x. How many times does 2x go into 4x? Since the answer is twice, I put it up here, and then I multiply, and I get 4x plus 2. Then I have to subtract, and I get 4x minus 4x is 0. 2x minus 2 is 0, so I get a 0. This means my remainder is 0. Since the remainder is 0, I know that 2x plus 1 and 3x plus 2 are factors of 6x squared plus 7x plus 2. So 6x squared plus 7x plus 2 must factor into these two factors. Okay, so I'm going to use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. So first thing I check is to see how many times 4x squared can be divided by x. Since that answer is 4x, I'm going to count over two terms, and I'll put 4x above the 23x. Next, I multiply, which gives me 4x squared plus 20x. Then I subtract both terms, and the 4x squareds cancel. I get 3x, bring down the 16, and now I divide again. 3x divided by x is going to be 3, so I put the 3 up on top. Multiply 3 times the divisor, x plus 5. That gives me 3x plus 15. Then I subtract, and the 3x's cancel, and I get negative 31. So I have 4x plus 3 with a remainder of negative 31. Since I have a remainder, I will turn the remainder into a fraction. So I'm going to say I have 4x plus 3 plus the fraction negative 31 over x plus 5. That's what I get. 4x plus 3 in this case is not a factor of our trinomial because there was a remainder. Here's one for you to try. Take 3x squared minus 29x plus 56 and divide it by x minus 7 and get your quotient and remainder. Okay, on this one I want to check and see if x squared plus 1 is a factor of this polynomial. So I will divide it and see if I get a remainder. So I'm going to take 3x to the fourth minus 4x cubed plus 12x squared. And I notice I don't have an x term, but I need one. So I'm going to put in a 0x as a placeholder for the x term. And then there's the constant term. Going to divide that by x squared. And again, the x term is missing, so I put in a 0 as a placeholder. And I'm dividing this trinomial into the polynomial. So I start with the first term. 3x to the fourth divided by x squared gives me 3x squared. Since I have 3 terms, I count down 3 terms and I put the answer here. Then I multiply, which gives me 3x to the fourth. 3x squared times 0 is 0. 3x squared times 1 is 3x squared. Then I want to subtract. So that gives me x to the fourth term cancels. Negative 4x cubed plus 9x squared. Bring down the x term. And now I see how many times x squared goes into negative 4x cubed. So that's going to be negative 4x times. So I put negative 4x up top and multiply it by the divisor. So it gives me negative 4x cubed. Multiplying by 0 gives me 0 again. Negative 4x times 1 is negative 4x. And now I'm subtracting. The x cubed terms cancel. I get 9x squared plus 4x. Bring down the 5. And now I'm dividing 9x squared by x squared, which gives me 9. So it goes up top. Multiply 9 times the divisor, and I get 9x squared plus 0x plus 9. And subtracting, the 9x squareds cancel. I get 4x minus 4. So I have a remainder of 4x minus 4, and that tells me that x squared plus 1 is not a factor because there is a remainder. So x squared plus 1 is not a factor. Here's one for you to try. When you set it up, make sure that you set up your term inside the box. This is x to the fifth here. There is no x to the fourth, so you have to put in a 0x to the fourth, a 0x to the third, a 0x squared, and a 0x, because all those terms are missing, and divide that. If the remainder comes out to 0, then it is a factor. You go ahead and try it, and that's the end of this video.